Hello guys, welcome to the DMS online school. If you are new to this channel, you are most welcome. And on this channel I teach mathematics, biology, science, and also revise past examination papers. So today's video is about the preparation of sorts. It's actually a summary following the previous video which I did on the preparation of sorts. So this video is done to help the information be cemented so that you are able to answer examination questions well without making errors. All right, just as I've said, the video is about preparation of sorts. All right, so we'll start with these questions here, which says describe how to prepare the following sorts. So we have sort number A, sodium chloride, which is represented by the formula NaCl, and B we have copper 2 sulfate with the formula CuSO4. Then C we have lead chloride with the formula PbCl2, and lastly we have magnesium nitrate with the formula Mg open brackets NO3 close brackets 2. So now, for you to be able to choose or select the correct method, you must ask yourself the following questions. All right, ask yourself these questions here. Question number one that you are supposed to ask yourself is this: is the salt soluble? The salt you are trying to prepare, is the salt soluble? If yes, then ask yourself another question: is it a sort of group 1 metals or ammonium salts? If yes, then use titration method or neutralization method. If not, then use displacement method or filter and crystallization method. All right, so we did these methods in the previous lesson. So if you didn't watch it, then you can click on the link appearing here. All right, so if the salt is not soluble, all right, if not soluble, then use precipitation or double decomposition. So these are the series of questions that will help you to arrive at the correct method. All right, so let's see how we can now start describing how to prepare the salts. All right, so let's start. So look, we'll start with the preparation of sodium chloride. All right, so we'll ask ourselves this question: is the salt soluble? This sodium chloride, is it soluble? Now remember, we said all sorts of sodium are soluble. All sorts of sodium are soluble. All right, so we are going to say yes, it is soluble. Is it the sort of a group 1 metals or ammonium ion? Now when you look at sodium, it's a metal from group 1, so we are going to say yes. Then use the titration method. That's how it is. So we'll use the titration method. All right, so we have concluded that the salt is a salt or a soluble salt of group 1 metals. That's what we have concluded from this series of questions. Then we have concluded that it is prepared by titration method. All right, so if this salt is prepared by titration method and it is a sort of a group 1 metal, then the reagents for preparing the salt are sodium hydroxide and dilute hydrochloric acid. So a sort of group 1 metal is not prepared using a metal and an acid, but it is prepared by a base which contains the same metal. So in this case, sodium here must be found in sodium hydroxide, and then the chloride must be found in dilute hydrochloric acid. So that's how you select the suitable reagents for the salt. All right, so now we are done. So let's look at the description or the procedure how to prepare this salt. All right, so the procedure goes like this. Step number 1: mix equivalent amount of sodium hydroxide and hydrochloric acid using titration process. So you need to use titration process in order to determine the correct amount of sodium hydroxide that must react with the correct amount of hydrochloric acid to reach neutralization point, because these salts, or because this is a base and this is an acid. So for you to be able to form a salt, these must neutralize each other. So for you to know the correct amount of the sodium hydroxide that must react with the hydrochloric acid, you must use the titration process. All right, so I'll be able to teach you about titration in the coming videos in future. All right, then the next step now, it is to evaporate the resulting solution to saturation point to get rid of excess water. So since it will form sodium chloride and water, so that water is not needed. We need the sodium chloride. So that water must be removed by evaporation. That's why we are saying evaporate the resulting solution to saturation point to get rid of excess water. So I said saturation point is a point at which some sodium chloride starts appearing as you do the evaporation. Or sometimes it is tested whether a solution has reached saturation point by stirring it with a stirring rod. When you stir the solution with a stirring rod, and when you remove the stirring rod and notice that some sodium chloride has started appearing on the stirring rod, then that signals you that the solution has reached the saturation point. Then after that, what you're going to do is to allow the saturated solution to cool naturally for crystals of sodium chloride to form. All right, so you leave some water of crystallization. That's why we heat to saturation point, so that some water, which we call water of crystallization, must remain. That water is the one which enables the crystals of sodium chloride to form. So the equation for the reaction is, this is sodium hydroxide, which is NaOH aqueous, plus hydrochloric acid, which is HCl aqueous, will give us sodium chloride aqueous plus the water. So this is the salt, this is the water which we drive out to remain with the salt. All right, if you are finding value in this video, guys, give it a like and let me know in the comment section, because it will help this video rank well in the YouTube search engine and also in the YouTube algorithm. All right, so let's move to another question, which is question B, which is talking about copper 2 sulfate CuSO4. So we'll also ask ourselves the same questions here. All right, so we'll say, is the salt soluble? Yes. Why? Because about the sulfates, we said all sulfates are soluble except the Kabale Sau. The Kabale Sau. So the Kabale Sau are the calcium, lead. Those are the one we said the Kabale. So we said the calcium, the barium, and the lead sulfate. Those are the insoluble one. The rest are soluble. So therefore, copper 2 sulfate will be soluble. So now we'll ask ourselves another question. Is it a salt of group 1 metals or ammonium ion? No, because copper is not of group 1. Then use displacement method or filter and crystallization method. So that's the method we'll use. Now, since copper 2 sulfate is not a mazit metal, or we are saying this copper 2 sulfate contains copper, which is not a mazit metal, then one of the reagents must come from a carbonate or insoluble base of copper. So since this copper does not reside among the maziti metals, what are they? M for magnesium, A for aluminium, Z for zinc, I for iron, then T for tin. So since it does not reside among these, it is an unreactive metal. So then it should be prepared from a copper carbonate or a copper of a base. All right, so now what are we concluding here? So we are concluding to say that copper 2 sulfate is a soluble base. All right, then it is used, or it is prepared by what? Displacement method. So we have said the salt is soluble, then it is prepared by displacement or filter and crystallization method. Excuse me. Then about the reagents for preparing the salt are copper 2 oxide and dilute sulfuric acid, or copper 2 carbonate and dilute sulfuric acid. So you have seen we have selected an insoluble base, copper 2 oxide, which must provide this copper here, and then dilute sulfuric acid, which must provide the sulfate here. We have said, or we can also use these. Copper 2 carbonate can provide the copper, this one, and then the same sulfuric acid, dilute sulfuric acid, which must provide the sulfate. All right, I hope you are getting something here. Please, if you haven't subscribed, please consider subscribing. I've seen most of you that are watching my videos here are not subscribers, so please, if you haven't done so, please support my channel by subscribing. I will appreciate greatly and continue doing what I do, providing great content for you. All right, so let's look at the procedure. So step number 1, you add excess copper 2 oxide or copper 2 carbonate to dilute sulfuric acid. So why are you adding excess? To make sure that the acid is neutralized or used up. Then we are saying you warm the resulting solution for the reaction to go faster. So the reaction of copper 2 oxide with the dilute sulfuric acid doesn't go fast, so you have to warm it for it to go a little bit faster. All right, so after that, then you have to filter off the excess copper 2 oxide or copper 2 carbonate, the excess that has not reacted because you added intentionally, so that the acid must be neutralized, and the signal to know that the acid have been neutralized is that excess part which remains. So it's very important that you put excess, because it helps you to inform that, or to get informed that all the acid has been used. All right, so the next thing that is supposed to be done now, after you have filtered off the excess copper 2 oxide, yes, or copper 2 carbonate, then you are supposed to evaporate the filtrate to saturation point to get rid of excess water. So there will be some water that will be formed, so you just have to evaporate that filtrate that you collected to saturation point to get rid of the excess water. Then you allow the saturated solution to cool naturally for crystals of copper 2 sulfate to form. Then the equation for the reaction is copper 2 oxide plus, so here I've used copper 2 oxide, guys, plus the sulfuric acid. It will give us copper 2 sulfate plus water. So the equation is balanced. All right, so let me show you the real picture of what happens with some illustration here. So the first step, when we said add excess copper 2 oxide or copper 2 carbonate to dilute sulfuric acid, warm the resulting solution for the reaction to go fast, the diagram is supposed to be like this. So this is the beaker in which there is sulfuric acid, and you add to it some excess copper 2 oxide or copper 2 carbonate, to make sure that when you add enough, there will be more here. You also heat, and what is not going to react will remain here, which is undissolved copper 2 oxide. So it will not dissolve. That which will react will dissolve and form a blue solution, and this blue solution, it is a solution of copper 2 sulfate that will be formed, because copper 2 sulfate has a color of blue. All right, so that's the situation here, guys. All right, so now when we say filter off the excess copper 2 oxide or copper 2 carbonate, is this excess here which has not dissolved, that you must filter here, put through the funnel. So the excess copper 2 oxide that hasn't reacted must remain on the filter. You throw it away. Then this copper 2 sulfate solution here is collected. So aqueous solution of copper 2 sulfate is here. That's where the copper 2 sulfate is. Then now when you do the evaporation here, where we said evaporate to saturation point to get rid of the excess water. This is what we are talking about. We heat here so that you evaporate. All right. So you evaporate so that blue crystals of copper 2 sulfate can form here. All right. Then what else? Allow the saturated solution to cool naturally for crystals of copper 2 sulfate to form. So you allow no heat now here. You remove the heat so that it causes for copper 2 sulfate solution to form, or crystals for blue crystals of copper 2 sulfate to form here. All right. So guys, let's move to the next question. So next question, let's look at lead chloride. So how can we prepare lead chloride? So we are looking at lead chloride. We'll ask ourselves the same question. All right. So remember, we said when we look at lead chloride here, this short way of remembering it, SiCl, Si for silver, then Le for lead. So here it is laid in full as silver chloride and lead chloride. So we said in the previous lesson that silver chloride and lead chloride are insoluble. That we must know. But however, there's another metal that I didn't mention which is also insoluble, mercury. So mercury is also insoluble. Mercury chloride is also insoluble. So I've written a short way of remembering it. Melis or Melis chlor. Melis chlor. So which means M for mercury, Le for lead, then Si for silver. You combine it. So you say mercury chloride, lead chloride, and silver chloride are insoluble salts. So these one are insoluble. Now, is lead chloride among these? Yes, this is lead chloride. So this lead chloride is insoluble. So if we ask ourselves this question like, is the salt soluble? We are going to say no, it is not. Then they're saying use precipitation or double decomposition method. So this one, not to worry about it. If the salt is insoluble, then we must use precipitation or double decomposition method to prepare it. All right. So what have we concluded? We have concluded that the salt is insoluble. Now, since it is insoluble, then it is prepared by precipitation or double decomposition method. All right. So guys, if you are getting value in this video, please let me know by liking the video and also commenting in the comment section. And remember, this coming holiday, which is starting next Monday, we are going to be having online tuitions in science and also in mathematics, because I've seen a demand, and if I will see that there will be more people also requiring biology, I'm also going to include it. All right, so that you guys are able to pass, providing you educative information that will enable you to pass your examination. So the charges are 60 kwacha science, and then 60 kwacha mathematics, and then 30 kwacha biology. Why I'm doing so? The work which is involved, guys, it's what I'm following. So when you pay me, then you buy my time, then I'll be fully committed to teaching you the entire month. All right, remember the 6th kwacha, if you use it for knowledge, the knowledge will remain in you for generation to come. But if you restrain yourself because you say, no, why should I give 3rd kwacha? I'll continue learning, and then you deny yourself knowledge that will enable you to pass in the examination. All right, so let's continue. So we are saying it is prepared by precipitation or double decomposition method. So the suitable reagents for preparing the salt are zinc chloride and lead nitrate. So this salt, lead chloride, must be prepared using zinc chloride and lead nitrate. So how do I know that I must use zinc chloride and lead nitrate? Wow, simple. So what we do for us to be able to know the salts that we must use to prepare this, or for us to choose the reagents, we must know that the reagents for preparing an insoluble salts must be two salts that are soluble, and one of those two salts that are soluble must contain the other part, lead, for example. Then the other salt also must contain the other part. So I chose zinc chloride because I know zinc chloride, it is a soluble salt, it is not insoluble. And it contains this chloride here, which is this one here. Then I looked for another salt that must give me the lead here. And I chose lead nitrate because I know the nitrate is soluble. All nitrate salts are soluble. So if I get two salts that are soluble, one that contains the other part of the salt I'm asked to prepare, then the other salt also must contain the other part of the salt also. Then these two, when they are mixed, they are going to exchange this ion or species. This lead will react with the chloride to form lead chloride, and zinc will react with the nitrate to form zinc nitrate. However, the zinc nitrate is not needed. What is needed is lead chloride. All right. So now let's see the procedure for carrying out this actual preparation. So procedure. Step number 1, you mix the solutions of zinc chloride and lead nitrate salts together. So they must be these in solution form. So you mix them together. So once you mix them together, a precipitate of lead chloride is formed. So there will be a precipitate of now lead chloride. So this one and this one, they will react to form an insoluble salt, which is lead chloride. And that insoluble salt is what we call a precipitate of lead chloride is formed. So what happens now? This other salt, which is zinc nitrate, will also be formed, but this will be soluble. So it will look like water. Then what will happen is now you are going to filter off the mixture to remain with lead chloride on the filter paper. So since these lead chloride and zinc nitrate, they'll be in the same beaker. So for you to remove the lead chloride, which is a solid, you must filter, because a solid will not be able to pass through the filter. But this zinc nitrate, it is soluble, so it will pass through the filter. So what will remain on the filter paper is the lead chloride. All right. Then after it remains on the filter paper, you wash the salt with distilled water. You wash it with distilled water to remove any impurities and any zinc nitrate that might have remained on it. Then what happens now? You dry the salt. That's all. So the equation is zinc chloride aqueous plus lead nitrate aqueous. It will give us lead chloride solid plus zinc nitrate aqueous. So it is this salt which would have formed. All right. So now the procedure now has been done. All right. So now let's see how this happens in reality. So in reality, when you mix the two salts, this is what you see. For example, if there was zinc chloride here, then you add here the lead nitrate here, you see a white precipitate here, or this one here. Let's say here there was zinc chloride, it will be colorless, and here if it is the lead nitrate, it will look colorless. But the moment the two mix, that white precipitate will be seen, and that could be lead chloride, that will be seen. Then it must be filtered off there, so that that colorless part will remain. It will go out, then some salts would be trapped on the filter paper here. All right, so that's what happens. So let's move to another salt here, which is magnesium nitrate. Magnesium nitrate. So now we know that when we ask ourselves this question, is the salt soluble? Then we should know that magnesium nitrate, we should use this one. All nitrate salts are soluble. So the answer will be yes, it is soluble. Then the other question is it a salt of group 1 metals or ammonium ion? The answer is no. Then use displacement method. So since it is soluble but not of this kind, then you must use displacement method. All right? So since magnesium nitrate contains a mazit metal, this magnesium nitrate contains a mazit metal, meaning it contains magnesium which is among these mazit metal. Then one of the reagents must be the metal itself and the dilute acid. So one of the reagents that we must combine to form this must be the magnesium metal itself, because it is among these mazit metals. Then also a dilute acid that must give us the nitrate. In this case, nitric acid must give us the nitrate. So let's see. So we have concluded that the salt is soluble. Then the method for preparing the salt is a displacement method of filter and crystallization. Then the reagents for preparing the salts are magnesium metal and nitric acid. So let's look at the procedure. So the procedure is that you add excess magnesium to dilute nitric acid. Then we are saying it starts to dissolve and bubbles of hydrogen gas are produced. All right, so when you mix this, so the magnesium metal will dissolve in the acid and then some bubbles of hydrogen gas are produced. Then we are saying bubbles stops when all the acid is used up. So the bubbles will help to know whether the acid is used up or not. So the moment bubbles will stop, then the acid has been used up, since we are using excess. Then you filter off the excess magnesium metal to remain with the solution of magnesium nitrate. That's what will remain. Then you heat the solution to evaporate some water to obtain a saturated solution. All right. Then from there you leave this to cool. Crystals of magnesium nitrate appear. All right. So now the equation for the reaction is magnesium, which is a solid, plus nitric acid, which is aqueous, will give us magnesium nitrate aqueous plus hydrogen gas. So you balance by putting a 2 here. So guys, we have come to the end of this lesson. If you have learned something in this lesson, give it a like. Let me know in the comment section. And if you haven't yet subscribed, consider subscribing so that you don't miss on the good information that is coming ahead. All right. Most of you are just watching and are not subscribing. I don't know, but I would love that if you subscribed and then support this channel. So guys, thank you for watching and see you in my next video. As for now, bye and please, peace.